Hello, and welcome to TypeScript Generics Practical Fun with me, Josh Goldberg. I am an independent open source maintainer in the TypeScript ecosystem. My main project is TypeScript ESLint. I'm one of the maintainers. We work on the tooling that lets you run JavaScript tools such as ESLint and PrettyArt TypeScript code. I'm also one of the maintainers of Mocha and on the committer team for ESLint. Lastly, I wrote the Learning TypeScript book through O'Reilly. So I like TypeScript and the tooling around it a lot. Speaking of TypeScript, we're going to cover 5 sections today regarding generics, an awesome feature in a lot of programming languages, including TypeScript. We'll start by covering the foundations of TypeScript types. We're going to introduce generic types and functions, what those are, some practical features and fun things you can do with them, and we'll end with some cautionary notes about things you might want to avoid or how to use them well. So okay, let's say hello to types and dive in from the start. What are types? Well, in order to go down that path for JavaScript today, we generally have to ask, what is TypeScript? Because TypeScript is the most popular way to do types in JavaScript. But to go down that path, if we really want to start from the beginning, we should ask something like, what is JavaScript? Which is where I'm going to start today. As many or all of you may know, at the JavaScript date, JavaScript is a programming language. It provides a standard set of syntax to describe values and how to use those values. Variables, string literals, assignments, and so on. The big problem with JavaScript, though, is that it doesn't provide a standard verifiable syntax for describing what each of those things is supposed to be. There's nothing you can put there in JavaScript that says, say, this value variable is only ever going to be a string. This code snippet shows it being first a string, then a number. Is that allowed? Was the developer originally okay with it being used that way? Who knows? So that's why we have TypeScript. TypeScript adds in a syntax like this colon number or colon string here, a type annotation, that looks a lot like JavaScript, but it's a superset. It's all of JavaScript plus this new syntax. So JavaScript is already somewhat complex. It's got a lot of stuff in it. Why are we adding these things? What's the benefit of adding in this new syntax for types? Well, types are a development time description for the expected shapes of your values. That's what it is, and over the course of this presentation, we'll see quite a few reasons for why we like that, things that they can help us do, or bugs that they can catch. Looking at it in practice, here we've already seen a nice little type annotation here saying the intent of this value variable is the built-in JavaScript type string. But we can make our own types, or type descriptions, our own shapes in TypeScript. Here, instead of saying built-in string, we're saying I'm making my own shape description called boxed, which refers to any shape, any value, in practice any object, that has a value property of type string. Later on, if we, having said that a variable is type boxed, assign it an object with value, say string ABC, that's okay, that's allowed, because we told TypeScript boxed.value is string, and that's what we gave it. But if we then assign, say, a number, that's not allowed because, well, that violates the contract. Okay. That's 3 minutes of recapping types. I apologize if you already knew all that, but I like to put us on a shared foundational footing of terminology for when we explore the really fun stuff, generic types. We like generic types because they allow us to make reusable types in the type system. Going back a slide, maybe we wanted to have a version of boxed for strings, and then also a version for numbers, and then a version for a bunch of other types. It would be really nice if we could make generalized or generic types that we can reuse to swap in and out different portions, but keep other parts of them the same. So we're going to talk about that for a little bit. What are generic types in TypeScript, and how do we define and then use them generically? To start, the real definition, or one of the definitions I like, is that generic types are those that have pieces that can be provided or swapped out every time you declare a new usage of it. I'll show you what I mean by that. Interface boxed of T. This is a, being very precise about terminology, generic interface. It is generic because it has a type parameter T declared on it. Notice how we don't say value string anymore, we say value T. We're defining that there is this type parameter T that can be swapped in every time we use it. Here we have let boxed, box of string, box colon boxed, which is saying as my type argument for T, I am providing string. So let's run through that terminology. We provide, or we give a type argument for the type parameter, t, which is what makes the interface generic. And I'm being very particular about my phrasing here because a lot of folks will sometimes use ambiguous or imprecise terms like I'm passing a generic. And that's not super wrong, but it can make it really hard to use like Google or ChatGPT or whatnot to learn more about these things. So I highly recommend, there's a great article, There Is No Such Thing as Generic by the Total TypeScript guy, Matt Pocock. Great article talking about how phrases like passing a generic aren't quite what you probably mean. Highly recommend it. But back to the interface. If we swap out from boxed string to boxed number, then TypeScript will know to give us a complaint. You said box.value is number, not string, but now you provide a string. That's wrong. What did you mean? If we swap back out to number, then we're happy. Yay, generics! Now, another way of thinking about this that I really like is that generic types are like functions in the type system. They receive type parameters and they output types. Their inputs are types, their output is a type. Now, if we look at the, say, interface boxed t, we could also think of actually like a runtime function that's kind of analogous to it, where both of these take in a t, and then you can call or declare with them, say, boxed of string on the left or boxed parentheses string on the right. And then they have an object that they return, this object shape with value string. So I think that's a cool way of thinking about things, that generic types like interfaces allow you to pass in, provide a type argument, and then using their type parameter, they give you back a new type. But however you're thinking about these things, welcome to the world of generics and TypeScript. I'm excited to be here with you. I'm going to take a quick detour from pure type system land to talk a little bit more about functions actually, because runtime functions can be made generic too. One really nice motivator is the identity function. This is a really common one in programming language theory. It's the function that does nothing. All it does is take in an input and return that same input. No other operations. How would you type this in TypeScript? For example, if you were to, say, provide a string, how would you set it up so that the return value is known to be type string? Well, you could explicitly hard code that value as string, which is great because then input ABC or identity of ABC gives you string, but then it's supposed to be reusable. We wanted to make this a generic function, so if you pass in number, we would have thought value would be number, but actually it's string, and you said the type of value is string, the parameter, so now this argument number is not allowed. So that's not it. A couple things you could try that won't work. You could try any, the YOLO, let me do whatever I want type in TypeScript, which is very unsafe, lets you do anything you want with it, and is kind of infectious. This function is now implicitly returning any, which is not what we wanted. You could use unknown, which is like a safer version of any, but still not what we wanted, and, well, unknown is annoying to work with. You have to verify that the value is a particular type before you use it. So that's still no good. The way we would actually likely want to declare our identity function is with its own type parameter t, making it a generic function. We declare this t here and then use it for the value runtime parameter, so that TypeScript can then infer in the TypeScript type system land, okay, this takes in a t and it returns that same t. For example, you call it with ABC, it infers that value is going to be ABC. And it's almost like we had declared the function when we're using it this way with string and an explicit return type string back. Then if you swap out to passing in number, it's as if we had declared it as taking in number, returning number. Hooray! Generic functions. So thinking about both functions and interfaces and, not covered in this talk, the other places you can use type parameters, those lovely things, those type parameters, allow input types to change your output types. They allow you to declare that this interface takes in a type that swaps out some pieces of it, or that this function has a type parameter which is then allowed to be used as the types of its runtime parameters. I think that's a cool way of thinking about things. It's a little head twisty when you start talking about different parameter types, so we're going to go back to learning about generics. Now that we know how these work with type parameters and interfaces and functions, let's talk about some of the things we can do with them. And because this is a practically oriented talk, I'd like to go through a few practical uses of real world code that I see a lot that uses type parameters and other generic things. To start, box, again. I've made a little create box function here that's a nice little equivalent to the box interface. Takes in a value, gives you back a box. If you call it with string ABC, then you get box of string. Box is a nice little example. You probably aren't writing interface box too much in your code, but you might be saying an interface result of t that maybe takes like a status boolean or number, and then some value t or some result t. Let's look at a bigger function that's got a little bit more stuff going on. This is a create state function. It's probably closest to what you might find in something like solid.js, but a little different. But it's generally the idea that a lot of UI frameworks have, where you have little pieces of state that you create with a function. How would you type this in TypeScript? Well, if we look through the function, it takes in an initial value runtime parameter, and that's it seems generic because it returns an object that lets you property get or property set on that initial value. So I'm going to make a generic interface called state of t that, given that t, has two properties: get, which is a function returning t, and set, which is a function that takes in t and returns void, nothing, ignore that. Ta-da, generics. Now this is something you might see in the wild, but I don't like giving huge, big examples in talks because I think I like going over the foundations of the syntax. So we're gonna not show anything at this level of complexity for the rest of the talk. But going back to this box interface container, I actually want to point something out that I think is really cool. Notice how, although we passed in the string literal ABC, we still got back box of string as the inferred, meaning TypeScript figured it out for us, type of the box variable. That's actually really interesting and touches on some cool programming language theory, because there's a difference between the literal ABC and the primitive string. Primitives are general data, like number, string, boolean, big int, whereas literals are specific instances of those built-in data types, 1, 2, 3, quote, ABC, and so on. And TypeScript, for our inference, inferred string, but it didn't have to. It could have inferred the literal ABC. And if we actually wanted it to infer the most narrow specific type, there is something we can use in the type system. It's called a const type parameter. If we augment or modify our t declaration to say it's const, that tells TypeScript that we want that most narrow literal version of it, the most even read-only for more complex data. And here, voila, we have gotten box of ABC instead of box of string. Now, you might be wondering, why is this useful? Why do we care about the difference between the primitive string and literal ABC? Aren't they all strings? Well, TypeScript is able to give you better assistance in development stuff when you use more specific, more not just accurate, but precise types during development. And just a quick pre-canned example here. It understands that if you compare two, say, literal types that aren't the same, that comparison is unnecessary. In this code, we know box.value is ABC, not just any old string. So it can actually give us a type error saying this comparison appears to be unintentional because the types literal ABC and literal DEF have no overlap. I think that's pretty nifty. So you probably won't do this very often, but once in a while it might be useful. Use const to indicate a type parameter should be inferred as the most narrow type possible. The most narrow type possible. I think that's cool. Anyway, moving on. Multic containers. Let's say that you wanted to have more than one piece of generic information being provided to your interface or function. For example, a create pair, like a key value pair. You might see this in like database wrappers or whatnot. How would you type this in TypeScript? Well, there are two generic swappable pieces of type here. Pair.key, which is in this case string or power, and pair.value, which is number or 9001. So I would create an interface with, fun fact, you can do this, two type parameters, key and value. Great. And then I'd have two type parameters on the function. Now, I'm not even explicitly indicating return type, pair, key value. I'm letting TypeScript infer the equivalent because this is kind of getting to be a lot of code. We've got like a half dozen instances, each of the word key and the word value in the first half of the code. So what you could do is you could abbreviate the names. Type parameters don't have to match up between different declarations and naming. This would save some space to go with K and V, but personally, I'm not a huge fan of single letter names like this, including for type parameters, unless it's just really clear what's happening. I mean, like 4 let I equal 0 levels of standardized. So personally, I wouldn't go with this. I would go with the longer names, but that's me. It's up to your personal preference. Either way, hooray! We are using multiple type parameters in an interface and a function. I think this is good stuff. And also, one last note, of course, the fun little const hint that we used before, the const type parameter, does work here too. So now we get pair.key is power, the string literal, and pair.value is 9001, the number literal. Awesome. Let's look at some more intense usage of generics. The get function. This is another classic. It was made popular in JavaScript land by older utility libraries like Lodash and underscore back in the day. How would you type this in TypeScript? Well, this takes in a container and a key and returns container next of key. So I think container should probably be generic here. And then because we want to get the value under attendee of the key, we probably want to make the key a generic, or rather a type parameter also. But then we get type K cannot be used to index type T. What's that about? This is one of the more common TypeScript complaints that people stumble on, myself included. Well, TypeScript is right. We told the function that T and K are some types, but we never restricted what key or K can be. We never said it must be something that exists on the type of container. We never said it's one of the properties of container, so TypeScript doesn't have the ability to verify, is this something that can actually be used as an index on T? We could provide, I don't know, something valid like name or interested, or we could provide something invalid like ASDF or the number 123 or null, and nothing in our types said we couldn't. Now, normally in TypeScript land, the way you would do this would be to declare key as a type that is an index, a known property container, such as with key of. Nice little built-in keyword there. But this isn't working because although there are no type errors, if you look at the return type of the function, get attendee interested, it doesn't specifically return Boolean or true, it returns string or Boolean. So it kind of works, but it's not exactly what we wanted. It's accurate, but not precise. And this is to be expected because in switching key from its own type parameter to a key of T, we've removed that relationship, that input-output pair in the type system between what key is and what the return type is. If type parameters relate a type of an input to the type of the output, we've severed that relationship. We've broken it up between the key and the return, which means TypeScript can infer what the type of the container is, but there's nothing allowing it to infer more specifically what key is being used. All it knows is that key is some key of T of the container, meaning container of key is any of the possible types under the values. We need some way to give key a type parameter, but also constrain it to the keys of T, a constrained type parameter. And we can do that in TypeScript land with the extends keyword, which constrains a type parameter to some other type, such as another type parameter. In other words, we can say that not only do we have this unique key type parameter for K, we can also say that K must extend or be assignable to key of T. And what do you know? It works. Const attendee, get attendee interested, the return type is Boolean. Hooray. And for the equivalent runtime code, give or take, approximately, it would kind of look a little like this, where we're saying that key is K, but K is the type of T, or the key of T. I'm kind of fudging it here with the second line. However you think about it, whether you're looking at it in the runtime code or the practical example, I think this is a really powerful thing that you can constrain type parameters to other types. Great power for us. Now that we've experienced the raw power that is generic type parameter inference, I want to dig a little more into that inference and actually show off how this stuff kind of works under the hood. To do that, I'll show one more function for now, and then we'll dive into this for a bit. Get index of, which takes a const type parameter t, an array of values, and a single value, and returns the index of the value. How would this actually work for inference? Meaning, how would, given a call like, say, this one, how would TypeScript know what the t is? Well, I'm just going to rearrange it a little bit. The way it would work is by looking at all the possible things, all the possible types that could be used as the type argument for t. And it just iterates through them and adds them to a big union type. Union type meaning a type that could be one or more of several other things, like string or boolean that we saw a few slides back. So first we see blue, which means it could be blue. Next iteration we see feta, so it could be feta, so now t is the union blue or feta, the literal. Then we go back to blue, and so okay, we already had that, which means voila, hello, get index of. The inferred type argument for the type parameter t is the literal of the union of the two literals, blue or feta. Awesome. Let's see what happens if we have a third version of a string for the value t. If we have a typo, notice that it's a different spelling of blue. Starts off the same, blue, feta, still a union, but then when we get to the third one, well, it's just yet another string literal, so we add it, and now we have the inferred type argument, blue or feta or typo blue. That's not great. And arguably, the developer, me, who wrote this function wanted it to be that you have to pass in a value that's t. That's one of the values in the array. So being able to expand the type inferred for t when you pass in some typo value is not ideal. I want to be able to stop inference on one of these runtime type parameter annotations. I want to be able to stop value t from expanding the inferred type of t. And once more, there is a TypeScript thing for this. It's actually relatively newer. A few minor versions ago, they added noInfer, which you can use to stop a type parameter from being included in type argument inference. I'll show you what I mean by that. If we switch value t to value this built-in generic type noInfer of t, we're telling TypeScript, shush, no, don't respect this. When you're doing the inference algorithm, don't use blue, which means don't add it to the union of possible types, which means it takes it out of the equation and gives us this lovely type error instead, saying, hey, we inferred blue or feta based off the other stuff, and this is some other thing. We don't like it. So hooray, we've used noInfer to throw something out of there, to make it so the type system doesn't respect that one parameter, and we get the right result. Nice. Those are a bunch of features, and I'm really happy about them, but I want to end with some cautionary notes, because generics go deep in TypeScript. We've seen identity, we've seen get, we've seen some stuff. I've even honestly omitted a lot of them. I haven't shown you map types and modifiers and conditional types, because those things, especially conditionals, can add logic in the type system, which then means you can do weird and wacky self-referential inference and bit arithmetic and binary arithmetic in the type system and all this stuff. And please don't. Unless you really have to, please don't. Because the more complex you make something, the harder it is to deal with. And as with any code, complex types should only be used to represent complex ideas. And we don't like complexity. We don't like complex ideas. Try to avoid complexity, complex ideas, if at all possible, especially in high-level app code. If you're working on like a generic data handling library and it has to do some wild and wacky stuff by virtue of how it's designed, and you can't avoid that design, then sure, maybe you have to dive into the generic stuff a lot. But if you're writing just like a high level, I don't know, Express or Fastify app or like React or Solid app, then try to avoid writing your own ridiculous fancy generic types. That's one piece of advice. When you are writing your own fancy generic types, though, a couple of pieces of advice for you. One, respect the golden rule of generics. I love this name. It's in the TypeScript handbook. It's also described in more detail in a great blog post from Dan Vanderkam, author of the very, very excellent Effective TypeScript. I'm not going to go too deep into this screenshot, but I do want to highlight type parameters should appear twice. If a type parameter only appears in one location, strongly reconsider if you actually need it. What does this mean? Well, A type parameter is supposed to relate an input to an output. So if you only use it for the input, or if you only use it for the output, there's no relationship there. There's nothing it's relating. And I'll show you a common example. The built-in TypeScript type, or pardon me, the built-in JavaScript function json.parse, by default in TypeScript is typed as returning any. So it's common for developers new to TypeScript to write something like this parse JSON t generic function, takes an input and says it returns t. But this type parameter here is unnecessary, and actually worse, it's unsafe. Because there's nothing that actually verifies that json.parse input, the any returned by that, is actually t. There's no relationship between input string, output t. And as an example, if you pass in some JSON that doesn't match what you thought it would, and then do console.log, whatever, some property that doesn't exist, that's going to crash at runtime with this 2 uppercase. You violated the golden rule of generics. That's not good. Now, there are some things you can do to get around the ability to violate this rule. You can respect the lint rule that we recently added to TypeScript ESLint, no unnecessary type parameters, which can actually validate that every type parameter you declare is used at least once. Now, using that rule, you might just say remove the t, or even set input to any, which is, well, that's one way to get rid of some type errors, no type complaints. But if you use more linting, which I of course recommend, you would then get a complaint that, aha, value is unsafe because value isn't any, because JSON.parse returns any. So then if you're nice and properly linted and you don't have any implicit any's or whatnot, you might say that input is string and the return type of the function is unknown, which means now you finally do get a TypeScript type error, value is of type unknown. Awesome. Low-key, I do feel a little smug that TypeScript ESLint rule has like a kind of nicer error message than TypeScript, but you know, they do a lot for us. No shade. Anyway, conclusion here. Lint your code. Linting is a very effective strategy to not completely eliminate, but severely reduce bugs and misuses of TypeScript in your projects, especially in larger ones. Now, I know there's a lot of stuff in the JavaScript ecosystem that can take up your time. Linting is one of those many things. Plus, when you have a larger code base, I know it can be a little bit of a pain to get typed linting with TypeScript ESLint set up. So no shade, no complaints if you just don't have the energy or don't have the time. But if you do, it's really valuable. There's a lot of great stuff in there, not covered in this talk, but at least you saw a couple of useful lint rules. So I highly recommend, at the very least, try onboarding to tseslint.recommended type checked. Our recommended type checked rules, lint rules that use the awesome power of TypeScript to give you better information. They're really nice. They're really useful. Okay, one last piece of advice before I wrap up. The TypeScript type cycle is one of my favorite things. This is a variant of the common term, the Gartner hype cycle, which refers to the kind of emotional journey most or all large new pieces of tech go through. You start off at the peak of inflated expectations, or for TypeScript, the peak of inflated types, which is where it's new and exciting and oh my gosh, look at all the cool stuff you can do. You can have generics and all sorts of features. But then when people overuse things, which in the case of TypeScript types, I have seen every TypeScript developer I've worked with for more than a few iterations go through this, myself included. You get to this trough where you overused it, you step back from the project, you come back, you have no idea what happened, why did you write all this stuff, it's completely incomprehensible, oh my gosh. Trough of disillusionment. But then once you've learned the hard way what the places you shouldn't do stuff are, and what the nice things are, you get to this plateau of productivity, this lovely space where you know how things are meant to be and when to use or not use features. And that's where TypeScript shines the best. Once you know when to use generic types and when not to use them. So the TypeScript party doesn't have to stop just because your generic types are killing you. That's a natural part of the process. Okay, let's recap for 20 seconds. I'm just going to blaze through these. If you are curious about types, they are development type descriptions for the expected shapes of your values. Generic types are those that have pieces that can be swapped out every time they're declared. There's no such thing as a generic. I use the term generics as the plural, but really type arguments are provided for type parameters. You can think of generics as like functions or type functions in the type system. Input types, output a type. A few features: you can use const to indicate a type parameter should be inferred as the most narrow type possible. You can use extends to constrain a type parameter to another type, such as the key of another type parameter. You can use noInfer to stop a parameter's type from changing the inference. And lastly, a few pieces of advice. Respect the golden rule. Type parameters relate input and output. They should do both. Please lint your code. Please, for the love of all that is holy, lint your code. And then don't be upset by the TypeScript type cycle. It happens to all of us. The trough of disillusionment is a natural part of the journey. Anyway, if you want to talk about any of these things, generics, TypeScript, types, open source, linting, I'm always happy to chat. You can find me as Joshua K. Goldberg on Blue Sky, Fosstodon, and Twitter. And lastly, thank you, JetBrains, for having me. This has been a blast. Talk to you all. Cheers.
So that was an awesome talk. I get hints of like C# definitely, because Anders created C# and TypeScript, so there's a lot of overlap. You begged people, Josh, to use linting, but I have the first comment for you. There are tsignore folks out there, and they mentioned we have a tsignore swear jar at work. So I imagine Paul actually has a tsignore macro on his keyboard. He uses it so much it's worn out at this point. So
I can understand that.
Yeah. So I guess a question related to that, like how do folks use linting to kind of move away from those swaths of tsignore into the promised land of type checking and better TypeScript code?
It's a great question. I think there's no one strong strategy. It's just a lot of small, strong strategies that all kind of feed together. If you don't have the time to like ramp up on TypeScript to become a true master and wizard in whatever terms we're using are the types, it's reasonable that you might have to any tsignore once in a while. That's fine. We all want to be perfect, but we have finite time and energy. A few tips though. First, use tsExpectError, not tsignore. tsExpectError is like tsignore. Thank you, Jan, for the aggressive head nods. It's like tsignore, but it'll create a new type error if there is no longer a type error it's suppressing. So like maybe TypeScript had a bug, or more likely your code had a bug that was later fixed in type system land. You'll no longer have this now useless comment allowed to be laying around. Also, in general, linting can help show that you have any's in your code, even though you never explicitly used any. And any's can cause a lot of issues. Sometimes they cause libraries like Zod to infer unknown or never instead of an actual type. So it's better to avoid any. Those are the two big strategies, along with just learn TypeScript if you have the time and energy and I don't know, general excitement about that area.
Mm-hmm. Yeah, I noticed when I pair program with Jan, if I ever type any, I see parts of his soul leave his body. Like just
sure.
He's just
it
like,
hurts
oh
me
no.
physically. and you're like technically like more mature in like this advocacy game, so I have to be respectful and not be like, oh
my God. No, there's no respect. There's no respect here. So, but anyways, Josh, there was something interesting about the code sample you were showing. Andre actually had an interesting question when you were doing generics. You had used interfaces instead of, say, types. Is there a situation where you prefer interfaces? Should people lean towards more interfaces, lean more towards types? Or is that just kind of the example you used in that situation?
This is one of the really annoying debates in the TypeScript community. It's annoying because there's no answer to it, which is why it very reasonably keeps getting brought up. It's a great question. Very reasonable.
Yeah.
In TypeScript land, most of the time, but not all of the time, there is no practical difference between using type something equals versus interface something. There are little edge cases where the two are different. Interfaces can merge. So like you can declare new properties on the global window interface, for example, whereas types can have unions and intersections that interfaces cannot. Few other differences. However, most of the time those aren't relevant. So most of the time it's best to just pick one and stick with it. So I'm just posting now. There's a lint rule in TypeScript BSLint consistent type definitions that says whatever your style is, just stick with it. Don't use the other style if you don't have to. There are some performance considerations around type. TypeScript, the project has mostly fixed most of those, but once in a while it's a little faster to use interface. But Otherwise, it's just a style thing.
Just to slightly add, this is completely correct. I don't want to like feel like this is not correct. I just want to mention that type augmentation is the worst feature that ever made it to TypeScript. It's not the worst. It's right under enums, but it's like,
Jan, tell us how
right
you really feel. Tell us how you really feel about this.
So coming from a software that does, or coming from a company that works on developer tooling, type augmentation is really hard to figure out. It's not fun. Don't do that.
Yeah.
I am curious though, like this question might change, or the answer might change to this question, considering like I know the JavaScript space is considering adding types, especially at runtime. So that could be a potential changer, but we don't know yet. That's completely speculation. This is a personal question for you, Josh. This is all opinion, no wrong answers. So somebody asked, how do you think generics can be improved? So it's great now, but it could be better. How do you think it could be better?
I've never been asked this question. There's a mantra. Some people say in opinions, there's no wrong answers. It's all wrong answers. This is a hard question to answer. I think the debugging story is tough. Like when you're writing complex generics, it can be difficult to figure out why things go wrong when they inevitably do. So I would love more assistance around there. This is not a TypeScript language thing. This is a TypeScript tooling thing. So I don't know how to do that, but I just know that the general user pain is as soon as you have more than a few lines and more than 2 type parameters or anything like extends or infer or no infer, then it gets hairy and no one likes that.
I do have a great tip for debugging for you. There are usually like a handful of folks that I approach. One of those is called, there's a guy on Twitter, it's called Josh Goldberg. And if I have a typing issue, I usually send him a DM with like a brief snippet and he comes up with an answer. So I don't know what it's doing. It seems like to be like some kind of debugging as a service kind of thing. So far I haven't received an invoice though, so I'm a little scared.
Yeah. I mean, it's an AI. It's not a real human.
It's an AI chatbot that's purely trained on TypeScript knowledge. So I do want to point people to your book. If folks want to learn more about TypeScript, definitely head over to Josh's site, learningtypescript.com, where you have access to his book there. It's a fantastic resource for anyone looking to kind of transition just from JavaScript over into TypeScript land. There was another interesting question. Let's see here. Let's say this kind of there's 2 questions. So both people mentioned React, but I'll ask this question. Let's say my React project uses TypeScript. Can I still add other projects that do not use TypeScript? And then additionally, the other question was, can I add other packages that don't use TypeScript without breaking my current app? So this is kind of a situation where maybe folks are mostly writing in JavaScript, but want to get into TypeScript because of things like generics and all the amazing features that are in your book. Should they be afraid? Do they need to go all in with TypeScript, or can they kind of buffet their way to TypeScript?
You can buffet your way into TypeScript. It's a great way of putting it. Very, very common and good question. Yes, TypeScript is very configurable. It's one of the, if not the most configurable mainstream programming language. And what I mean by configuration in this context is you can tell it to be less aggressive when there are parts of your code that are untyped. For example, you can make it so that it's totally okay with you having untyped parts of your code where everything is the any, the YOLO, I don't know what I'm doing type. Don't yell at me. That's totally reasonable. In fact, the general recommended strategy that a lot of people, myself included, give for you have a large JavaScript code base and you want to turn it to TypeScript is don't do it all at once. Don't change any runtime code during the conversion. Convert single or a few files at a time to TypeScript gradually over time as you learn more about TypeScript, so that until the end of the process, you always have some JavaScript, some TypeScript. So yeah, you can definitely go incremental. You can definitely add non-TypeScript stuff to your TypeScript project.
Okay.